Welcome back, everybody. Today we have Mr. Jagathdeva Vidanagama presenting one of his own papers. Mr. Vidanagama, it's floor is yours.
Thank you, sir, and good afternoon, everyone. So, using this research paper, I'm going to explain much about the importance of life cycle assessment and how we can contribute to do life cycle assessment and improve the quality of life cycle assessment in Sri Lankan context. So, I'll explain much details during the presentation. So before going to the paper, so let me explain what is the life cycle, because I'm sure this is quite new for most of you. So I'd like to give some brief introduction about the life cycle and life cycle assessment and the methodology. Then only I can explain my paper and the later developments after publishing that paper, because it was done in 2018. So after that, I have some more analysis with the data to complete my the thesis. So you can see in our life we consume a lot of products, right? So each and every product has its own life cycle, from raw material extraction to final disposal. So the raw material extraction can be either agriculture or mining, and from that, the raw material extraction point to the final disposal point, so that product life cycle has a lot of impact, connection with the environment, a lot of impact to the environment. Right? At the very beginning, in the raw material extraction, we take that raw material from the environment, right? The resource extraction. So then after that, we have to transport it, we have to process it, refine it, and the product manufacturing, then again transport, then finally we use the product, and then after using the product, we dispose it, and finally again it goes to the environment. So during that life cycle, there are a lot of different type of impacts to this environment. So in this life cycle assessment, so basically what we do, we assess that impact and try to minimize the impact using that result. So that the impact can be different type of impacts. So far, according to the literature, so officially they say there are about 18 impact categories, including the impact to the climate change, impact to the ozone layer depletion, ecotoxicity. There are so many impact categories. In some products may have impact to the climate change, but there's no impact to other impact categories. If you think about the life cycle of a product, actually we can identify mainly 4 or 5 phases. The initial part is the raw material extraction. So where we get the raw material, then pre-processing of the raw material, then product manufacturing, use and disposal. So if you talk about the rubber sector, so the raw material extraction is kind of natural latex rubber at the rubber plantation from the rubber tree. Then we have pre-processing, different types of pre-processing, like crepe rubber manufacturing, centrifuge latex, RSS, different type of raw rubber products. Then product manufacturing, it can be a glove manufacturing, it can be tire manufacturing. Then we use that products in our day-to-day activities, and finally we dispose the product. Whatever the products available in the market or in our day-to-day life, so we can categorize into 4 types. You know that there are 4 phases, basically 4 phases in the product life cycle. There are set of products which have high environmental impact in the pre-production or raw material extraction phase. So the first one you can see on your left, like the packaging materials. So compared to other phases of the life cycle, the pre-production is significant. There are another set of products, the production phase is significant, compared to other three phases, like the laptops, papers, and that type of products. And there's another type of product category that the use phase has significant impact to the environment, right? Like the automobiles, the condominiums, washing machines, whatever, right? So during its use phase, it has some impact to the environment compared to other phases. And there the other set of products like the diapers and all, so impact is high at the end of life phase, but not in the pre-production, production, or use phase. Actually, life cycle assessment was originally initiated several decades ago as a tool to assess the environmental impact. But that's why we normally when we say the life cycle assessment, it refers to LC, sorry, environmental assessment, kind of environment assessment. But now there are some developments. Actually, now we can find life cycle costing. That means that the economic part of the life cycle, the value addition and all that. Then the social life cycle assessment is there. That means in entire the product life cycle, we assess the social impact, right? The raw material extraction, what is the impact to the people? Is it safe for the people? Or in the production phase, do they use child labor? And use phase, is it harmful or unhealthy for people? And disposal phase, what is the impact to the human, right? So that is another area in the life cycle assessment that is called the social life cycle assessment. So the combining environmental life cycle assessment, life cycle costing, and social life cycle assessment, now we can find another development that is called the life cycle sustainability assessment. So covering all social, environment, and the economic part. So the life cycle sustainability assessment is there to assess the sustainability of product life cycle. So in our life cycle assessment, normally we say it's a cradle to grave approach. That means the raw material extraction to final disposal. So during that life cycle, we can identify several system boundaries. For example, actually, when we do a life cycle assessment, it is not necessary to cover from cradle to grave. It depends on the intended purpose and the requirement of the assessment or the study, right? Some cases we just cover the cradle to gate. That means raw material extraction to the finished product dispatch. For example, in the Putlam cement work, so when they do the life cycle assessment, they started from raw material extraction at their quarry to final product dispatch. So then they said instead of saying the cradle to gate, they said the quarry to lorry. Right? Some cases we can identify, for example, the food product from farm to fork, right? That farm to plate or something like that. Right? So depends on the requirement, we can set the system boundary. Sometimes it can be cradle to grave, which covers from raw material extraction to final disposal, or cradle to gate, that the raw material extraction to the product dispatch without use and disposal phases, and can be gate to grave. That means that covers use and disposal phases. Like, in basically we can do LCFO gate to gate. So that means it covers only the production phase. The gate to gate means normally the manufacturing facility, they have two gates. That is one for getting raw material and one to dispatch the product. So that's why it says gate to gate, right? From raw material receiving to the product dispatch. In life cycle assessment, in the general methodology, according to the ISO standards and other the manuals, so there are 4 phases. So basically, when we do LCA, we cover all 4 phases. Right? Sometimes we can avoid phase 3 or phase 4. Some people do LCA considering only the phase 1 and phase 2. But to have a much broader idea about the environmental impact, so we have to cover all 4 phases. So the goal and scope definition is the starting point. Then you have to prepare the life cycle inventory and inventory analysis, then impact assessment, and finally, so we have to interpret that result into the application. So for decision making or whatever. So I'm going to discuss this life cycle assessment approach using this the research paper, because for my research, so I do life cycle assessment, cradle to gate life cycle assessment in local tea and rubber manufacturing sectors. That means that in tea sector, from tea plantation to the product dispatch at the factory, that cradle to gate, and the rubber products from raw material extraction at the rubber plantations to the value-added product manufacturing phase. So using this research paper, so I'm going to discuss, but I must say I have more results after publishing this paper, so I'm going to show the results and the comparisons and all so during the presentation. So in the goal and scope definition, it is the first phase of the life cycle assessment methodology. So in here we define the goal as the goal of the study was to quantify and compare the GHG emissions associated with energy usage in tea and rubber industries, and identify significant GHG emitting sources and phases in the product life cycle from raw material extraction to manufacturing. Right here, it's only about the energy, but we cover the rest of the emission sources. So I'll show the results, but this paper is only for energy use related greenhouse gas emissions. So it's a partial life cycle assessment, as I just explained. Now it is covered phases such as raw material extraction, pre-processing, transportation, and product manufacturing. So this life cycle assessment does not cover the use and disposal phases of the life cycle, right? And it also considered GHG emissions associated with energy use only, but I have the results of other emission sources, so I'll show you that. In the tea industry sector, the system boundary covers tea plantations, transportation of green leaf, tea processing, then biomass as a source of thermal energy, and bulk packaging. In rubber sector, we covered the rubber plantations, transportation of natural rubber latex and raw rubber products, the processing of intermediate or the raw rubber products like the crepe, RSS, centrifuge latex, and TSR, then value-added rubber product manufacturing. So we identify several energy sources like the purchased grid electricity, that is electricity from the national supply, then diesel, petrol, fuel oil, and biomass. So when we do a life cycle assessment, it is compulsory and it is necessary to define a functional unit. So because all the results we get from the analysis, we have to relate it to the functional unit. Now here in my study, the tea sector functional unit is 1 metric ton of made tea. So that means whatever the results, emissions or raw material use or energy use, whatever we relate that into 1 ton of made tea. So then finally we say the result, okay, this amount of greenhouse gas emissions when we produce this 1 ton of made tea or 1 kilogram of made tea, whatever, right? So it's we relate that result to the functional unit. Then rubber sector, so 1 metric ton of dry rubber content. That normally in the sector they say the DRC content. That means that because natural rubber has rubber and the water and other chemicals, so normally when they refer the dry rubber content of natural rubber, so that's why in rubber sector, we define the functional unit as the dry rubber content, the 1 metric ton of dry rubber content. Actually, we gathered the data from local industries, because when we do a life cycle assessment, the main problem is the data, the activity data. But there are several approaches. One is we can get the data from secondary sources, or we can get the data from international databases like EcoInvent, and there are several other databases. But when because we want to do something related to Sri Lanka, so we decided to collect our own data, because then we can say this is very specific to our country, and this is very specific to our products, manufacturing processes and facilities. So that's why we collected our data from our local industries, and almost all the data we got from the primary sources. When we prepare the life cycle inventory in this paper, it's only the energy, but we have all other non-energy activity inventory data. Then the life cycle impact assessment, we mainly focus on the impact to the global warming and climate change. So because our research was designed to that aspect, that impact category, to assess that impact category. But there are several other impact categories. But when we do the analysis using the CIMA-Pro, the modeling, so we assess the impact to the other impact categories. But our main focus was the impact to the climate change and the global warming. So in this analysis, we considered the 3 main greenhouse gases out of 6, CO2, CH4, and nitrous oxide. So these are the rubber and tea cultivation areas in the country. So, only in the wet zone. The first step, so we map the process and identify the system boundary. So this is the system boundary of the tea manufacture, the life cycle of the tea. So we cover the tea plantation, transport, then the processing and made tea transport. So we identify all the inputs and the waste streams. So similarly, we repeated the same activity for rubber sector, considering 2 types of rubber products, dry rubber products and the centrifuge latex based products. When we collect the data for tea sector, so we gather data from about 70 tea plantations and small scale tea holders, and 68 tea processing units, that means manufacturing facilities, so covering all the tea growing regions in the country. In rubber sector, so we gather data from 40 rubber plantations and the transportation part and processing units, the raw rubber processing units, as well as the finished, the value added product manufacturing facilities, covering another about 20 manufacturing facilities. And the data, actually this is the important one, the grid emission factor. So that means in Sri Lanka, when the TB, when they generate electricity, what is the emission? So that is available in their publications, the Sustainable Energy Authority. So we use this data. In 2012, when they produce 1 kilowatt hour from thermal energy, the emission was 0.735 kilograms of CO2. That means when at home we consume 1 kilowatt hour from thermal energy source, that means that is the amount we emit. All right, and that year the thermal fraction was 71%. That means the amount they generated the whole year, the 71% from thermal. but in 2013 it was 40% with the availability of the hydropower. In 2014 it was 62%. And we use IPCC global warming potential values for methane and nitrous oxide when we estimate the equivalent carbon dioxide quantity. So the life cycle inventory phase, we prepare once we set the goal and scope definition. So then we develop the life cycle inventory. So considering collecting those data from tea and rubber sectors, we collected data of energy, raw material, other physical inputs, the products, core products, and there are so many data sources and emission sources. So we identify emission sources and we collect the relevant data. For example, when they transport green leaf from a small place, small tea holders to the factory, they use different type of transport modes like trucks or different type of trucks. So we identify the what type of trucks, then fuel consumption per kilometer, and estimated all the emissions associated with the transport. So they have about some tea factories, they have about 15-16 channels that collecting lines, right? So we collected all the data relevant to that, the types of lorry, the way, the road conditions and all. Then we estimate the emissions associated with the leaf transport, because the case to case that the values are different. Sometimes in a good road, even the distance is high, but the emission is less. But in hilly area, it's very bad road conditions, the emission is high. So we collect all the data, talk to that people, the drivers and all. So because we wanted to get that more accurate values when we prepare the inventory. So this is the inventory results we calculated for energy sector. The plantation, there are three energy sources: electricity, diesel, petrol. In green leaf transport, it is only the diesel consumption. The tea processing purchase electricity, diesel for their standby generator, biomass for thermal energy, and diesel for biomass transport. So, and we have high grown, mid grown, low grown, and over region data. So later on, we had we prepared this the overall inventory results. Right, the plantation is in addition to the electricity, diesel, and petrol. So we estimated the quantities used for like the fertilizer and other chemicals, agrochemicals, dolomite, urea, and other inputs which may have some impact to the climate change. And leaf transport, it's only diesel. In the processing, electricity, diesel, biomass is same as it's only energy sources. But in plantation, there are set of non-energy emission sources. In rubber sector, again the same practice, the same exercise. Plantation, the raw rubber processing, there are several types of raw rubber products. The crepe and RSS we combine together. Electricity, biomass, diesel for standby generator, then centrifuge latex, the mainly electricity. So likewise, then DSR, unfortunately we had only one factory. And value-added rubber product manufacturing facilities, there are two types. One is centrifuge latex-based products and the dye rubber products. So we separately collected the data from their facilities and prepare the inventory. This is the rubber sector energy and non-energy inventory results. The combined one, the plantation, they use sort of in addition to the energy, they have the chemicals, fertilizer inputs, and even the crepe and the raw rubber processing processing activities, they have a lot of chemical usage like different oxalic acid, the ammonia. So once we prepare the inventory, then we have to assess the impact from that inventory result. So so in that product life cycle, we use energy, other chemicals, other fertilizers, or whatever, and then we want to assess the impact to the environment. So in the impact assessment, so this is the basic the process, the methodology we follow, right? The first here, so we define the goal and scope, then we prepare the inventory, and now we are in the impact assessment part, right? So with this, so this is the requirement example, right? So this is the inventory result. So we have this much of emission, this much of electricity, this much of waste water, whatever, right? So using that inventory result, so we assess the impact, or okay, then it's what is the impact to the climate change, what is the impact to the acidification, so what is the impact to the eutrophication, land use, resource depletion. There are so many impact categories, so we can select one of those or several impact categories. But when I read the literature related to the life cycle assessment in the world, the most of the researchers selected the climate change as the impact category, or some cases climate change plus several other impact categories, because in the world now it is the main environmental problem. So in most of the cases they select the climate change impact category, or only the climate change impact category, or climate change impact category plus several other impact categories. So with that result, we assess the then we go into the endpoint category. I'll discuss that later. Right? The midpoint and endpoint impact categories. When we do the impact assessment, we have environmental interventions like raw material extraction. So whatever the inventory results here, right? The inventory results. So based on that inventory results, we assess the impact. Okay, impact to the climate change, impact to the resource depletion, impact to the land use. Likewise, there are several impact categories. So in our study, so we just selected the impact to the climate change. Right? So that is our impact category. And these are the midpoint impact categories, and we have endpoint impact categories. Okay, that climate change, what will be the endpoint? What will be the damage to the environment? So there are three areas of protection. One is human health, resource depletion, and ecosystem quality. Right. So depends on the impact to the each and every areas of protection. So then we combine the climate. Okay, then take the human health. So okay, there is a resource depletion. Let me show in the next slide. Yes, here this environment intervention, the life cycle inventory results. So based on the results, we identify the midpoint impact category, and with that we identify the damage pathways and relate that midpoint impact to the endpoint area of protection. So what is the damage to human health? What is damage to the ecosystem? Damage to the resource availability. So in our study, we only mainly focus on the impact to the climate change. That means the global warming and climate change. So we using that results, the inventory results, we calculated, we estimated the impact to the climate change. Now here you can see from GHG emissions from energy use in tea sector in four regions, the comparison. Now the total emission in high grown is something 514.27 kilograms per ton of made tea. That means when we produce 1 kilogram of tea, that emission is about 0.5 kilograms of CO2. But in here you can see the averagely in Sri Lanka, when we produce 1 kilogram of tea, the energy related emission is about 0.55 kilograms of CO2. That is only from energy use, right? So, but when it comes to other sources like the N fertilizer and all, nitrogen fertilizer, the biomass, whatever the other resources, so the picture is different, right? Now you can see here greenhouse gas emissions associated with cradle to gate scope 1 and 2 was estimated. So I'll discuss what is it, scope 1 and 2. That is the direct and indirect emissions. The indirect means the purchase electricity, like that, right? It's about 1.6 kilograms. Now, I think here the energy related emission is only 0.55 kilograms of CO2 per kilogram of the made tea. But here, if we consider all the emission sources, it's 1.64. That means the energy is not the significant emitting source in the tea sector. So you can see the nitrogen fertilizer is the significant emitting source. When we compare the energy use again, now we compare the three phases of the life cycle: the plantation, leaf, transport, and processing. Energy related emissions are high at the processing part. Of course, in processing they use a lot of electricity, but emissions are quite low at plantations and transportation. So you can see even here the transportation related emissions are low at high grown, because in the setup is different in high grown compared to other three regions, because in high grown they have large state and that larger tea estate and state owned tea factories. So the transportation is quite low. So they can collect the green leaf from their own plantations. But in low grown and over, so they process a lot of bought leaf. That means they transport leaf far away places. Small tea holders and the tea growers supply the green leaf. So that's why the transportation related emissions are quite high at low and mid grown in even over region. Emissions from all sources, again the life cycle phase wise GHG emissions. The tea plantation is the main contributor, right, because of the application of the fertilizer, and the leaf and biomass transport and the tea processing. So if you focus on here on energy, energy, the main contributing part phase is the processing part. But if you consider the overall, the total energy and non-energy emissions, so we have to focus on the tea plantation, because the plantation contribution is significantly high compared to the leaf, transport, and tea processing. Another comparison, the energy and non-energy emissions, right? So you can see the energy related emissions are not significant here. The non-energy part is quite high. And another comparison, GHG emissions from scope 1, 2, and scope 3. So in life cycle assessment, we normally define three modules in the life cycle. Shall I explain that one? In here now we consider from plantation to the factory gate. So that is the core module. And when in the plantation we use nitrogen fertilizer. The manufacturing of nitrogen fertilizer has its own life cycle, from raw material extraction and the processing and all, and bring the product here as the final product to the plantation. So that scope 3 covers that part. That means the upstream process. So likewise the diesel. So we calculate that in our scope 1 and 2, we calculate the emissions happens at our place, or we burn diesel at our plantation or the power generation. But in scope 3 covers emissions associated with the crude oil extraction, crude oil refining, then transport and sea transport, land transport, and bring it to up to our place, right? So those are called scope 3 emissions. So we estimated scope 3 emissions as well using that modeling tool. So you can see here now in some inputs we have only scope 3 emissions. For example, so electricity have both scope 1, 2, that means we use electricity here, and to bring that electricity here, the associated emissions are there. But in glyphosate, that once we apply that chemical in our field, it doesn't emit anything related to the climate change. But when they manufacture that product, it has some emissions, right? So that's why. So you can see that the blue color line is not there, only the orange color one is there. Then urea, of course, in the site emission is comparatively low when it compared with the urea production. In the dolomite, the manufacturing, that upstream emission is low, but the on-site emission is high. So see here now, the interesting thing, when we consider the nitrogen fertilizer, upstream and the scope, that means scope 1, 2 emissions are almost equal to the scope 3 emissions. That means when they manufacture and bring the nitrogen fertilizer up to our place, emission is almost equal to the emissions associated with our application related emissions. Using the modeling tools, we assess the other impact categories as well just for our information. So midpoint impacts, the plantation to mate tree life cycle regional comparison. So these are normalized values, right? Because you cannot, we cannot compare the climate change impact with the ozone layer depletion, right? So to compare, we have another tool called the normalization. So we use the normalization and we bring that different types of results with different indicators into one graph, so that we can see the level of impact. So in tea sector, you can see according to that normalized values. We don't know what is the modeling part inside the software. So sometimes they use their own data, the developers use it, because that's why we say if we have our own kind of models to assess our impact, sometimes the picture may be different, right? So still we don't have it, but we just use that type of the already available models to assess the other impact categories and the normalization. So you can see the climate change impact is quite low compared to other impact categories like the natural land transformation, then the agriculture, land occupation and all. So, but even human toxicity, because the use of the fertilizers and all, then freshwater purification. So in climate change impact is comparatively low, just to give an idea, right? So we can't say it's not significant here, but it is a normalized value, and we don't know the actual impact values. So in the rubber sector, the same analysis, right? The phase-wise GHG emissions, the plantation, then the crepe and RSS processing, centrifuge latex, then centrifuge latex based product manufacturing and dry rubber based product manufacturing. So you can see the value addition part has more contribution compared to plantation and that the raw rubber processing phases. These are phases, right? Now here the product. Now the crepe rubber manufacturing, this is the emissions. It's about 0.5 kilograms per kilogram of DRC. In centrifuge latex, it's quite low, but the dry rubber has emissions of about 2.25 kilograms per the kilogram of DRC input, and even centrifuge latex, the result is quite high, but those are more value added products, right? So we can earn a lot compared to exporting crepe and RSS product, because with that value addition, sometimes we may have gained per dollar earning. The rubber sector emissions, the total results, right? That the electricity from dry rubber, all the sources are there. So see the contribution, right? Electricity in dry rubber product manufacturing is the main contributing source. Then electricity centrifuge latex, then fuel oil, dry rubber product for the thermal energy. So likewise, we analyze all the contributing sources, and so now with this result, if we want to mitigate the climate change or reduce the impact, to reduce the climate change impact, so very clear now we have to focus on significant electricity or energy using areas in the rubber sector, like the dry rubber product electricity. So if we want to mitigate it, to introduce technology or find solution or find alternative method, so we have to focus on these high emitting sources. So then we can easily reduce some percentage of greenhouse gas emissions. So in the interpretation part, so we want what are the impacts, the inventory result, we interpret that result into our to fulfill our requirement. There are some results. This is only for energy, right? So tea, when we produce 1 kilogram of tea, this is the contribution, the crepe rubber, and actually the comparison of 4 products, the 3 rubber products and the tea. Yeah. Now this is only for energy, but this is covering all the emission sources. So made tea production, again the second highest emitter. The dry rubber value added products more than 2.25. Likewise, you can see the results, and this is another interesting one, right? Okay, so we know that dry rubber product manufacturing emission is quite high compared to other products, but in our local value addition is also high. So to get an idea, so we analyze the GHG emissions per US dollar earned, right, when we export our product. Now you can see when we export and earn $1 US, so emissions associated with the tea is quite high compared to rubber products, right? So that means when we earn $1 by selling our tea or exporting tea, we have this amount of greenhouse gas emissions. So if we want to reduce our footprint per dollar earned, so we have to focus on that areas and reduce the emissions. But here it's if we export the crepe or RSS, per dollar emission is low, right? So but we have to think about this is only for the impact of the climate change. So in that type of situation, so we have to think about the social impact, the job opportunities, and all other things, right? So we cannot make decision based on this, but these are decision support results, so they can consider this if the decision makers or the policy makers want to make a decision to reduce the carbon footprint of tea or other rubber products or other exports, right? If you want to export something to other countries, so for example, in future, according to the European Green Deal, if you want to export some products to Europe, so if we can export something carbon neutral, so they don't have any tax for that, right? So but if you have the carbon plus product, that means some footprint, so then we have to pay the tax, right? So in future, so they are going to implement that Green Deal. So in that process, so we have to have carbon neutral products to get the maximum benefit and the market advantage. Emissions and sinks, right? So far we discussed about the emissions. Now we have another part here, the sink, that tea and rubber plantation, the carbon sink potential, right? So in tea sector, scope 3 emissions, scope 2 emissions are here, and the soil carbon also uh, absorb some carbon, right? And even biomass. So according to our results, we have net sink in T sector. That means the absorption is high compared to the emissions, the both scope 1, 2, and 3. That means even covering the upstream processes, right? So for the marketing purposes or the tea manufacturer, sometimes it's a good advantage, because so now here we have covered only the from cradle to the gate. That means the product manufacturing. So when they sell their product, they can say, okay, now they have excess amount, right, that the product is neutral, the negative, right? Then sometimes they can offset the user's footprint, right? If you buy our tea, we have already absorbed the emissions associated with the tea making process related emissions. So that type of the potential is there. I don't know how they use it, but that potential is there, because now they say we have already absorbed the emissions will occur when you drink this tea or whatever, right? The product and use this product, whatever. And the emissions, GHG emissions and sinks in rubber sector, right? Both the dry rubber products and centrifuge latex products, so both have a net sink because you know the rubber plantation, rubber tree, it absorbs a lot of carbon, and you know during the 25 to 30 years period, so sequestrate a lot of amount carbon. So when we compare the emissions and the absorption, so absorption rates are quite high compared to that associated emissions from raw material, that's the plantation to the product manufacturing. So that what I said, that opportunities are still there for even rubber sector. So sometimes the rubber product manufacturers can use that results to offset the emissions will occur in the product use phase. So finally, these are the applications of LCA results. So I just use the research work and the results to show how we estimate or assess the impact, right? This is only for the impact to the climate change, because we selected that impact category, but other researchers who are interested, you can select other impact categories. Let me show you. So there are so many other impact categories. Sometimes those are relevant to you, your subject areas, and also you can select one of those impact categories and so assess the impact from significant that the impact to the climate change, or impact to the ozone layer, or impact to other impact category. And here, so we can use this the LCA results for several purposes. The one is the product development and improvement, right? So once we do the LCA, now we have the results. Okay, but this amount of energy use, this amount of resource use, this amount of fertilizer, right? So we can design some products to minimize the environmental impact using the LCA results. So there are a lot of examples in the world, and we can design products for sustainability using the LCA results. So then identify energy and resource efficiency improvement potential. So as I said, if you consider the energy related emissions, so we have to focus on tea manufacturing phase and the dry rubber product manufacturing phase, right? So once we identify the potential area, so we can improve the energy efficiency and resource efficiency. Sometimes, so in rubber sector, if we can, in tea sector, if we can minimize the fertilizer use, the nitrogen fertilizer use, we can reduce the carbon footprint and other environmental impact, right? So those are the opportunities we have using the LCA results, right? Then it is a very good tool to compare the alternatives, the potential possible alternatives, objectives, and product comparisons, right? Which is good, which product is good. I heard that recently when the government banned the sachets, so some people have done even LCS actually to get to make that decision, right? So that potential is there. Then strategic planning purposes at the national level. So LCA results basically we can use in two different levels, the micro level decision making as well as macro level decision making. And the micro level means at organizational level, they can use LCA for their product development, marketing, and R&D, whatever. At the national level, we can use a life cycle assessment results for developing the raw material strategies, energy strategies.
I'm pretty sure that it's quite relevant. Thank you, Jagat, for the interesting presentation, because with the, I can see a lot of applications, and also, the fertilizer ban, for example, a classic example, I guess, right? To evaluate these sort of things, fertilizer, organic fertilizer to chemical fertilizer, which is better, which is the bigger devil, or the, of the weevils, which one is the more evil. But plantation sector, any product, yeah, I think this is very relevant. I'm pretty sure there are interesting questions and comments. Over to I will just act as a mediator here.
Sorry, I could not unmute the mic. Sorry. Thank you very much, Jagat, for the presentation. Very interesting. And as Sampath also pointed out, I would like to know, now we have this new development going 100% organic. So do you think by converting ourselves to 100% organic, using 100% organic fertilizer, would that be beneficial in reducing a significant amount of greenhouse gas emissions?
Actually, if you want to compare that with the chemical fertilizer and the organic fertilizer, so we have to select two products and do the life cycle assessment to compare the results. So, but just I cannot say which is good, which is bad, because as I said, now we get the results compared to unit of product output, right? Sometimes when we use the chemical fertilizer, the output may be, the harvest may be high, right? So when we relate that that per unit of output emission, sometimes I don't know, because I can't say directly which is good, which is bad. But the best thing, so we have to conduct a life cycle, the proper life cycle assessment, and they analyze the results, selecting the relevant impact categories. So impact to the climate change, or impact to the water, or ecotoxicity. There are so many impact categories relevant to that fertilizer application. So best thing, prepare the life cycle inventory of two products, so the chemical fertilizer, that means the manufacturing plus use, or just consider the use part, and get the harvest results and all, and compare the inventory and the impact results. So then we can show, using the kind of scientific approach, so this is good, this is bad, this may have much more positive points. And sometimes nitrogen fertilizer, so we can, that climate change impact is high, and other impacts also high, right? We just talk about the climate change, but we don't know that the impact to the ecotoxicity or damage to the water or soil from chemical and the organic fertilizer. So we have to assess, considering those impact categories, and do the comprehensive study. So otherwise, actually, we cannot just say this is good, this is bad, because it's misleading actually. Because in LCA principles it says, so if you want to compare two products, do a proper LCA with the same assumption, same scope, same system boundary. Otherwise, we cannot compare it. In LCA software, even we cannot compare the two LCAs with two different versions of the software. Right? The same data, but we cannot compare. So the best thing, they carry out proper LCA organic fertilizer and the chemical fertilizer with the output. That means the harvest, right? Sometimes organic fertilizer harvest may be low, right? In the chemical fertilizer harvest may be high. So it depends, right? Directly we cannot say, but the best solution is to do a life cycle assessment.
Thank you, Jagat.
Thank you.
Good luck to you.
Thank you.
I have in that light, it's very, yeah, it makes sense. Similarly, like Jagat, I know that similar comparisons or harsh criticism for oil palm, because they are wild, and then there's oil palm ban now. And I know Nihal sir and some of his students done some biodiversity assessments of oil palm plantations versus rubber and tea, and oil palm clearly has more diversity. So, I mean, I personally also think that oil palm has fair bit of diversity, and but it has very negative image in Borneo, what is happening to Bornean rainforest. So, so has anybody done LCAs for these across plantations? I mean, like the one you've done with tea and rubber, to compare other plantations like cinnamon and oil palm?
Oil palm, there are, but not in Sri Lanka. But I have some research articles was published in Malaysia, Indonesia, that region, because they are doing this cultivation. So there are some papers doing LC analysis, not only the impact to the climate change, even they have considered other impact categories. Right.
And Jagat, in the LCAs, the way you given the weightage for a particular element, wouldn't that be biased? Like, like say from a biodiversity angle, I would give more weightage on say rainforest, erosion of rainforest, erosion of native diversity, and so on. Somebody, an economist, would give more emphasis on the cost of production, the wastage, and so on. So would they, like, how you standardize these, because these are two-sided knives, isn't it? Because somebody would use the same procedure to justify a very evil product, so how you standardize?
No, Dr. Samba, now it's very clear. Now, once we prepare the inventory in proper way, that means those are the obvious data that we can gather. That is a straightforward thing. And even midpoint impact categories, so we if you know the inventory data, we straight away we can calculate the impact, right? So if you are interested in biodiversity, it's a different way of calculating that one. My interest in climate change is a different, but if you want to combine or identify the trade-offs, then only that the subjective weightage and that matter comes into the picture, right?
But it's there, isn't it? But it's there, isn't it?
Yeah, it's there. It's there. That's why I said now when you can see this, this one, right? So these are normalized value, right? So now see the impact from the climate change and other impact categories, right? So we don't know what is happening inside, because the model was developed in Europe or somewhere, and we don't know what are the weightages they have given. Sometimes in climate change is not important for them, right? So in their context, sometimes it is not important. They may have some more significant impact categories, like ecotoxicity, human toxicity. It depends. That's why I said if you want to compare two impact categories and identify trade-offs, so that subjective matter will come, right? So it sometimes, if you are interested in biodiversity, sometimes you neglect the climate change part sometimes. So I mean, in my case, I don't know the biodiversity, so I don't care about the biodiversity. I just focus on the climate change and several other impact categories.
The danger would come with like somebody would put a lot of emphasis on their business community would pay more attention on economics turnover, and then the clash comes again, the same old story where and then this kind of indices could be used in a very malicious ways
Yeah.
as well, right? The standardization, I think, is also a very important critical point here. Right?
But up to midpoint impact categories, so that process is straightforward. So that is scientifically proven, indicate that the factors and all they are. So, but if you want to the impact to the human health, so there's a kind of gray area in this life cycle assessment. Still, we need more research and the indicator development and all that. What you say is very correct for that, the latter part, that the endpoint impact category, and compare the normalization weighting. So those are very subjective. But that up to the midpoint impact analysis, so that is very straightforward. Then that, but it again depends, because this is only the environmental part. As you said, the life cycle costing is another part, right? Social life cycle is another. But when you do the life cycle sustainability assessment, sometimes we have to give some weight for other the social part, the costing and economic, and we have to consider the all three bottom lines.
I see. Yeah. Any comments? I mean, the other issues, I'm just giving some thoughts onto this, like, empowerment of communities, empowerment of minorities, women, children, all these also comes into play, global West and East issues, right?
Yeah. So we can develop that type of things in social life cycle assessments, because those are still developing stage. So we can even add something, or we can customize those methodologies to our context. So that opportunity is there. Yeah. Sometimes we can combine the environment plus social and develop some indicators or metrics to assess how we assess the life cycle impact, social and environmental, in plantation sector or different agriculture sector, whatever. We can identify sector and develop something. So that potential is there.
Jagat, this is our Preeti.
Madam. Yeah, madam.
Very interesting presentation, because I learned a lot as I'm not aware of these things. I just, one small question I saw in one of the slides, you had mentioned diseases such as cancer. Can you elaborate on that, please? As to how diseases sort of
impact categories.
Yes, impact is another. Yes. Cancer, non-cancer.
Madam, now these are the impact categories developed by scientists. So actually, even I don't know some the real impact of these categories. But we in my case, I know much about the global warming and the climate change, right? So, but in life cycle assessment, so another one can do the inventory result and convert that result into the one of these impact categories. Sometimes the person want to assess the impact to the water use or impact to the freshwater ecotoxicity. So in that type of situation, we get the inventory result and identify the potential impact from that particular the chemical or whatever.
Okay, that means to human.
So these are impact categories, madam. Now, because
I understand. Yes,
single person cannot be expert on
no,
these.
Sorry, I'm sorry if I put you in a spot, but it's just that
is a different, because sometimes, madam, now the asbestos and something, the carcinogenic, that meaning some chemical, right? So then we can, there's a method to assess the impact to human toxicity. That means the cancer part, and human toxicity non-cancer. So that means there are two impact categories here. So we can select the calculation methodology, impact assessment method, then assess the impact.
Right. Okay. Thank you, Jagat.
Thank you.
Mr. Jagat, I'm Nipuni.
Yes.
Thank you very much for the informative presentation. I just want to know, now we see both in tea and rubber plantation, when we compare the GHG emissions due to energy sector, they act as net sinks. So if we combine all the emissions with the energy as well as the non-energy sectors, will it be most probable to become sources? I was just wondering.
Sorry,
so
I couldn't get the last part of the question.
So in these emissions categories, they were basically based on the energy GHG emissions. So if we consider both energy as well as the non-energy GHG emissions due to the fertilizer applications and all, so will it be probable to become a net source rather than a net sink?
Net source, that means emissions. Now here,
yes.
Now according to this study, now we have scope 1, scope 2, and scope 3 emissions are comparatively low to the sinkages of from to the soil and the biomass carbon, and that's why it's carbon negative.
Yes.
Right. So, but we can say that because it's a kind of a scientific study. But if you want to use these results for marketing or whatever, so then we have to follow the protocols available in the carbon footprint calculation and all. Right? So with that protocol, sometimes we cannot use the biomass sequestration part according to that protocol. In that some cases, so we have to mitigate, right? We cannot promote the offsetting sometimes, right? So that is there. For example, if you want to the carbon pricing instruments, the carbon tax or whatever, so then when they set the maximum, the ceiling cap emission, so they have to, they cannot exceed the upper limit, right? They have to reduce their emissions, but sometimes they cannot emit, right? So their available option is the offsetting, right? But they cannot do 100% offsetting in some cases according to some standards or protocols. So in that type of situations, we cannot use our biomass carbon sequestration or soil carbon sequestration to offset our emissions, right? So it depends. But this is a study, the scientific study. So we can show that this process, okay, the tea manufacturing process, sinkages are quite higher than the emissions, right? But if you want to get the economic value of this, or if you want to use this for our marketing purposes, then we have to follow the available protocols or standards or related to the carbon footprint, carbon neutralization, so that type of things. So in that type of situation, according to their standards, sometimes we cannot use our own the plantation to sequestrate our emissions. For example, in tea sector, if you can say, then according to this study, you can say, okay, this even we can offset scope 1, 2 emissions as well as scope 3 emissions using our the soil and the biomass of the tea plantation. But according to that standards, they don't allow us to do that, right? If we want to offset, we cannot use our own tea bushes to offset that one. So if we want to offset, we have to grow another plantation or forest plantation or something to offset that one. So that is the requirement if you want to be carbon neutral or carbon negative, right? Sometimes we cannot use our own that are even the same, that is same similar for that is the same situation we face in rubber plantations, right? You see down here the thing is quite high, but we cannot use rubber plantation to offset the emissions associated with the rubber manufacturing process. So that is not allowed.
It's a nice cross-cutting topic, Jagat. Very exciting. It's very interesting, and I think it's highly relevant for everybody. So thank you very much again.